I wanted to make a few points about the z-score of a sample mean. I want to show you how the z-score of a sample mean really works the same way as the z-score of an individual person. First, a sample mean that's below the population mean will have a negative z-score. A sample mean that's equal to the population mean will have a z-score of 0, and a sample mean that's above the population mean will have a positive z-score. Also, a sample mean that's far below the population mean will have a z-score far below 0, and a sample mean that's far above the population mean will have a z-score far above 0. So, a sample mean that highly underestimates the population mean will have a z-score that's far below 0, and a sample mean that highly overestimates the population mean will have a z-score far above 0. Overall, a z-score shows how extreme a sample mean is. If a sample mean is far below or far above the population mean, then that sample mean will either have a big negative z-score or a big positive z-score. Let's take a look at the z-score formula one more time. I told you that this was the z-score formula right here, the sample mean minus the population mean divided by the standard error. We know that if the population is 20 times larger than the sample, then the standard error formula is just this short formula right here. It doesn't have that FPC at the end. So if the population is 20 times larger than the sample, then this is the formula for the z-score of the sample mean. Let's use this formula to calculate the z-score of a sample mean. So we know that IQ scores in the general population have a mean of 100 and a standard deviation of 15. What this question is asking is that if a sample of 50 people is selected from the general population and the mean IQ of the sample turns out to be 107, what is the z-score of the sample? To answer this question, we have to turn the sample mean of 107 into a z-score. We can do that using the z-score formula. We just have to subtract the sample mean of 107 by the population mean of 100, and then put the standard error on the bottom. The standard error is just the population standard deviation of 15 divided by our sample size of 100. Our sample size of 50. Let's go through the steps to find the z-score. This is just subtracting on top. We subtract 107 by 100 and we get 7 on the top. That's our first step. Next, we can find the square root of 50. We can just enter 50 into the calculator and get the square root. The square root of 50 is 7.07. Next, we can divide on the bottom of the fraction. We can divide 15 by 7.07. When we divide those two numbers, we get 2.12 on the bottom. So far, we've subtracted on the top, then we found the square root of 50, and it came out to this number. Then we divided 15 by this number, and we got 12.12. We just have one more step. We have to divide 7 by 12.12, and then we get our z-score. So this sample of 50 people has a z-score of 3.13. A z-score of 3.3. To get the z-score, we subtracted the sample mean by the population mean, and we got 7. Then we found the square root of 50, and it came out to 7.07. Then we divided 15 by 7.07 and got 2.12. Then we divided 7 by 2.12, and we got the z-score. And it makes sense that this z-score came out to a positive number because the sample mean is above the population mean. Now we'll move into some questions in which we actually use the z-score of a sample to find the probability of getting a certain sample mean. A sampling distribution follows a normal distribution, meaning it has a normal curve, or at least a roughly normal curve. Then it's possible to use the z-score of a sample to find the probability of getting a sample mean lower than a certain number, the probability of getting a sample mean higher than a certain number, or the probability of getting a sample mean between two certain numbers. We'll go through an example of each type of question. And before we go through these questions, I want to mention that it's only possible to find these probabilities when the sampling distribution is normal. And the sampling distribution is normal, or at least roughly normal, in three situations. Those three situations are taking a large sample from a skewed population, taking a large sample from a normal population, or taking a small sample from a normal population. In those three situations, it's possible to calculate these three types of probabilities that I'm showing you here. If you're taking a small sample from a skewed population, then the sampling distribution actually isn't normal. The sampling distribution is skewed, and in that situation, it's not possible to calculate these types of probabilities. So the following steps are needed when, to use a z-score to find the probability of getting a sample mean below a certain number. First, we have to calculate the z-score of the sample. I already showed you how to do that. Then the next step is to actually go to a table called a z-table and look up the z-score. When you look up the z-score, it actually tells you the probability that you're looking for. It tells you the probability of getting a sample mean below the number that you're interested in. And the following steps are needed to find the z-score